All right, video on 12.2 for factoring. So 12.2 standards officially says I can write a quadratic expression as a product of its factoring. As a product of its factors. So what does that really mean? Factoring is this. If I said to you factor 24, well, factoring 24 looks like this. See, I factored 24. I can also factor 24 like this. Either way, what I'm doing is I'm writing 24 as a multiplication problem. So if I just gave you this, that's a math problem, 8 times 3, and obviously it gives you 24. So factoring is just making multiplication problems. You are making a multiplication problem. So that means I'm giving you something that looks like this. If I said factor, and let's make up a few problems, like here's a, 7x squared plus, 21x maybe. Problem B will be something like this. And we'll do one more that's like a little weirder. Just a few weird ones, okay? So notice, remember what I just said. Factoring is making multiplication problems. There is no multiplication going on here. There's a multiplication happening here, but I'm not talking about that. I'm talking about between the stuff. 7x squared and 21x are not being multiplied. There's a big fat plus sign between them. Big fat minus and plus sign. Big minus sign. So notice, how do I know when I'm in 12.2? You are looking at a problem with no parentheses. So if you've got a problem like this one, where there are no parentheses, or this one where there's no parentheses, or this one there's no parentheses. If there's no parentheses, you are not drawing the insides of a box. You're not drawing the outsides of a box. Parentheses mean multiplication. You are not multiplying. You are not multiplying. I'm not giving you a multiplication problem. I am not giving you a multiplication problem. I'm giving you an addition problem. The addition problem is like this. If that's 15 and that's 5, then the area of the whole thing is 20 because I am adding 15 and 5. So here's what I gave you. I gave you an addition subtraction problem, which means I'm giving you the inside of the box. So the key here is if you do not see any parentheses, you are doing the inside of the box. And so when you make these boxes, you're always going to start like this. If it doesn't work out, then we fix it, but you're always going to want to start like that. And you start by taking that first x squared component, whether it's an x squared or an a squared, it will always go in the top left. And then you look for the back number, not a number with a letter, not the thing in the back, the number in the back. Do you see the difference? We're not looking for the number like that's in the... You were not looking for like the last number. That would be like 21. And I'm not talking about that because 21 is with the X. I'm talking about the number that's all by itself with nothing attached to it. That would be 20 in this case. And that always goes in the back corner. Always this, always this, always from matching this and this. Once you have that inner box filled in, then you're going to want to fill in the top left corner outsides. You don't want to fill this in. Don't worry about that 9x. That's not this part yet, okay? Can't do that just yet. So I'm going to fill in this with an x and that with an x. That makes sense. X times x is x squared. And then, again, I don't want to worry about this diagonal. What I want to worry about, what I want to focus my attention is whatever I put here and here has to give me 20 by multiplication. So whatever I put on this piece here and this piece here, we're multiplying it. So the first thing that comes to mind is 10 times 2. 10 times 2 does give me 20. So as soon as I have an idea that something times something gives me this, that's where I want to get started. And let me show you where I made a mistake because that's not right. But again, you don't really know that going in because these are like logic puzzles. You got to try some things before you figure out if you're right or wrong. So once I figure out that this and this is a match, then I fill in the rest of the boxes. So this would be a 10x and this would be a 2x. And that diagonal together better be the middle. If it's not a match, then something went wrong. So if we add 10x and 2x together, 10x and 2x is 12x. 12x is not what I have in the middle. that means I made a mistake. Nothing bad happens. All that means is you just have to undo some of the work you did. It means that the 10 and the 2 that you chose weren't the right answer. 10 and 2 does give us 20, but it doesn't give us the right diagonal. So that means it has to be there from start to finish. So the 10 and 20 isn't right. So if you think about another term, another two numbers that multiply to 20. 5 and 4 is what comes to mind too. 5 times 4 gives me 20. So now that I've double checked that these two things give me this, now I fill these in. That gives me 5x. That gives me 4x. I check the diagonal. 5x plus 4x is 9x. That's not what I have in the middle. It's really darn close to what I have in the middle though, which is a good sign. I have a 9x. I need a negative 9x. So that just must mean I need some minus signs. So the 5 and the 4 I think are right. I'm just going to add minus signs to them. And I'm going to double check. Negative 4 times negative 5. Let's see if Siri agrees. Siri, what's negative 4 times negative 5?
Negative 4 times negative 5 is 20.
Do you see? She agreed with me, okay? So now I'm going to fill in the rest of the boxes. Negative 5x, negative 4x. Check the diagonal. This negative 5 and that negative 4 does give me this. Perfect. That's exactly what I wanted. And now, instead of focusing on the insides, because that's how I started the problem, I started the problem by putting x squared and 20 on the insides. So I remember what the goal is. The goal was to factor, to make a multiplication problem. If you're making a multiplication problem, you are using the outsides. So I'm going to take what I have on the outsides and just put some parentheses around them. X minus 4, x minus 5, ta-da! That's it. That's your answer. You went from an addition problem to a multiplication problem. You went from a no parentheses situation to parentheses. That's exactly what we want. We went from adding and subtracting to a multiplication problem. It's just like this. You're going from 17 plus 3 to 4 times 5. I gave you 17 plus 3. You gave me 4 times 5. We're talking about the same number. I give it to you as an addition subtraction problem. You're giving me the answer as a multiplication problem. And they're the same because they're the inside and outside of the same box. Okay, so let's recap. You get a problem. There's no parentheses. So automatically you know you're filling in the inside of a box. The x squared term always goes up here. The number in the back that's all by itself goes in the bottom corner. And then you do some multiplication. You're like, okay, now let me fill this in. I need an x and I need an x. So you might be thinking, I don't know, 4 and 1. Two numbers that multiply to 9 or to 81 are 9 and negative 9. So I'm just going to fill some things out and see what happens. 9 times 4x is 36x minus 9x. Uh-oh. These two things, 36 minus 9 is 27. I don't have 27 in the middle. In fact, I don't have anything in the middle. So you might be panicking. You might be like, oh my God, I don't know what I'm doing. But we start the way that we always start, which is there, right? Like we start with the 4x squared in the corner. We start with the 81 in the lower right. And then what I notice is that I have nothing in the middle. So again, I'm starting the exact same way I started this one. But when you don't have a term in the middle here, that's a dead giveaway for these being the same but opposite number. Because if these go away, if I had a 10x and a negative 10x, well, negative 10x and 10x make nothing, and that's exactly what I want. I want no x's in the middle, and I can only have that happen if these numbers are the same, like a 20 and a negative 20, a 4 and a negative 4. And the only way that that can happen if these numbers are the same and opposite. So what I mean by that is to get an 81 happening here, we need 1 9 and we need a negative 9. Same, but opposite. And the same thing goes here, but this is going to be an opposite situation. So to make a 4, we're not going to use 4 times 1. We're going to use 2 and 2. And obviously we're going to put x's in there because otherwise we wouldn't have an x squared. So remember, we always need an x here and an x here for this box. And now watch what happens. 9 times 2x gives me my 18x. negative 9 times 2x gives me a negative 18x, which is exactly what we want, because when we put 18 with negative 18 together, we get nothing. So we go from the inside of the box to the outside of the box in parentheses, because remember, I gave you a no parentheses problem. You give me a parentheses problem, and see, ta-da. We went from, I don't like the way I drew that, an inside the box problem where you started with a 4x squared minus 81 on the inside, and we went to the outside. And the reason this one's just a little bit different than this one is because we're having matches here where these numbers are opposite. Okay, so that's a nice little problem where it's a little bit more unusual. Let's do one more. This will be our last one. I don't know how long this video is. I always intend on making them short, and I never do. Okay, here's your box. You start with 7x squared in the bottom, or sorry, the top left. And then you're like, okay, I'm going to put a number in here. The number that goes here is the number in the back. There is no number in the back. So that means you're not going to put anything here. And if you're not going to put anything there, you're not going to put anything there because they're in the same row. So don't worry about that. We don't need that. Ta-da! So if we're filling in the inside of the box, and I filled this 7x squared in here, the only common sense thing I probably could figure out is to put that 21x. Remember, when I'm giving you a no parentheses situation, I am giving you the inside because those things get added. Adding boxes gives me the big box, right? So if you're like, I don't know how to do this problem, do it the way we've done B and C. Start with this 2 by 2 grid. That number goes here. If you are missing a number, fine, cross it off, and that should tell you to cross out that whole row and then fill in the rest of the inside box with that. And then we're gonna for sure have an x and an x here. I can't leave that x squared without x's here and here. And so then I'm thinking, okay, can I take a number like 7? Can I put it here? I think I can. And if I put a 7x there, then I would need to put a 3 there. And the reason for that is 7 times 3 is 21. So the answer then is, again, remember, I gave you the inside of the box, so you give me the outside of the box. The 7 and the x are trapped. If you want to put them in parentheses, that's fine. The x with a positive 3 on the other side, and that's your answer. You went from an inside the box problem to an outside the box problem. And don't worry, if there's not something to put here, just cross this part out and stick with a box that looks like this. Okay? Hope that helps. Sorry for the long video.